computers and the devices related to us, printers, routers, modems. And then we also trying to know about the OSI and TCP IP models. Then we are read about the LAN, what is the local area network, wide area network, WAN, Ethernet explained what is the Ethernet and how it's work, MAC and IP addresses. This is also a very important topic related to basic computer and networking. Also, we are going to trying to know about the unicast, multicast and broadcast addresses. Which type of addresses, IP addresses are the unicast, multicast and broadcast. And the last one we have the network devices. And so in this video we capture some network devices queries. So let's start. First we have the what is a network. In a simple language, if we want to say what is a network, then if we have connected one or more computers within a centralized device is called a network. Also, one or two computer is connected directly is also called a network. So a computer network can be described as a system if interconnected device that can communicate using some common standards called protocols. This device communicate to exchange resources and services. That means in a network the device are able to exchange the data and file and resources and services. Here is an example network consists of two computers connected together. We in the next example we have the two computers PC1 and PC2. These all are connected with the LAN area, LAN wire. So this is a network of two computers only. In the example above, the two computers are directly connected using a cable. This small network can be used to exchange data between just these two computers. That means in this network we are only able to transferring and receiving data between these two computers, not any others. So what if we want to expand our network? Suppose you are working in a big organization, you are working in a small organization. There approximately 20 and above computers. Big organization has the 100 and 200 and 400 computers. So what we do when the network is explained, then we can use a network device, either a switch or a hub, to connect more than two computers together. If we are trying to expand the network, then we have need a centralized device called switch or hub, and the all computers are connected with the same devices. So here is an example, a network with a hub. Here is a you can see in a central device hub PT, and these hub are connected with the four different computers. Now all of the device on the network can communicate with each other. Here the four computers are very simply communicate with each others. That means the computers are able to exchange the resources and services between in the four. We will talk more about hubs and switches in just my coming videos. For now, just remember that these devices serve as a central point to which all of the computers connect to. Second, we have the OSI and TCP IP models. First, we have the OSI models. So, OSI stand for Open Systems Interconnection. Model was created by the International Organization for Standardization. It was a design to refer and describe the function of communication system. That means OSI is the design for the describe the communication system between the different layer of devices like the router, switches, computers, Wi-Fi, printers. So how the all devices are communicating each other. So OSI layers defined it. The OSI model provides a framework for creating and implementing network standards and device, and describe how networks application on different computers can communicate through the network media. That means the basically OSI describe the communications between the networks. The OSI model has 7 layers. which person have some knowledge of computers and networks, they all are aware about the OSI. But for the beginners, you all have to know about the OSI have a 7 layers, with each layers describing a different function of data traveling through a network. Here is the graphical representation of this the layer. So we have the first layer is a physical layer, not go upon up to down. We have the first layer in the down, and then we have to go the up and up and down. So first layer is a physical layer, second layer is a data link layer, third layer is a network layer, fourth layer is a transport layer, fifth layer is a session, sixth presentation, and seventh we have application. So these seven are called the OSI layers. The layer are usual numbered from the last one, meaning that the physical layer is considered to be the first layer. It is useful for to remember this layer, since there will certainly be a couple of questions on the CCN exam regarding them. If you are going to give exam related to CCNA, then you have to face some questions about the OSI and TCPI models. So most people learn the mnemonic, please do not throw sausage pizza away. This is the short form where you can easily remember the OSI layers. Here, please denotes physical layer, do denotes data link layer, not denotes network, throw denotes transport, sausage denotes session, pizza denotes presentation, and away denotes application. So if you have you remembering this, please do not throw sausage pizza away, then you can easily remember the OSI layers: physical, data, network, transport, session, presentation, and application. In the next, so what is the purpose of this layer? They are most common used by the vendors that enable them to implement some functionality into a network device, which then enable easier interoperability with device from other vendors. That means these all layers are used by the vendors who's creating and who is the manufacturing the layer devices. Like you have all are seen the some switches are manageable or some switches are not manageable. Yeah, that means we have if you have a D-Link switches in your network, then you can see the some D-Link switch has a plug and play. You just nothing doing in this switch. You have to insert a main cable of computer and insert the others cables and in computer, and the all computers are connected with each other. So this is the called a plug and play switches. Also we have some managed switches where we can manage the VLANs, we can manage the ports. That switches are called managed switches. So who can define who creating these managed switches or non-manageable switches? So these all created by the vendors. So vendors are using these OSI layers to manufacturing devices of network. Here is a brief description of each layer of the OSI. So let's see. First we have the physical layer, defines how to move bits from one device to another. That means in a physical layer, data traveling in a bits. It details how cable connectors and networks interface card are supposed to work and how to send and receive bits. Data link layer encapsulations a packet in a frame. That means the data link layer, the all data traveling in frame. A frame contains a header and trailer that enable device to communicate. A header most commonly contains a source and destination MAC address. A trailer contains the frame check sequence field, which is used to detect transmission error. The data link layer has two sublayers. Data link layers have also two sublayers. The first one the LLC and second one the MAC. Logical link layer, LLC used for the flow control and error detection, and second MAC is called media access control, used for hardware addressing for each controlling the access method. That means the all network and computer have a unique MAC address, so the all device are easily communicate to each other with this communication. Third layer we have the network, defines device addressing. routing and path determination. Device logically addressing is used to identify a host on a network by its IP address. That means the network layer defines device addressing. That means which type of address configure in the device is defined the network layer. Transport layer, the segment big chunk of data receiving from the upper layer protocols, establish and terminates connection between two computers used for flow control and data recovery. Sixth, we have the session, defines how to establish and terminate a session between the two systems. And the last one, we have the presentation layer, defines data formats, computers and encryption are defined at this layer. That means the all encryptions and compressions of the data defines on this layer. Application layer, this layer is the closest of the user. It enables network application to communicate with the other network application. That means the application is layer is the last layer, is directly interacted to the users. So it is a common practice for to reference a protocol by the layer numbers of layer name. For example, HTTP is referred to as an application or layer 7 protocol. Network device are also something described accordingly to the OSI layer on which they operate. Example, a layer 2 which or a layer 7 firewall. So that means we in the next slide we are going to know which layers using which type of device and which layer are using which type of protocols. The following tables show which protocols reside on which layer of the OSI. So let's see. Application layer use the HTTP protocol, presentation layer use MIME protocol, session layer use SSL NetBIOS protocol, transport layer use TCP UDP protocol, transmission control protocol and user datagram protocol. Network layer using IP and ICMP, internet protocol and IP configuration message protocol. Data link layer use PPP and SDLC and physical layer use the Ethernet protocol. Next we have the TCP IP model. So let's see, the TCP IP model was created in the 1970 by a Defense Advanced Research Project Agency DARPA as an open vendor neutral public networking model. Just like the OSI model, it describes general guidelines for designing and implementing computer protocols, network access, internet, transport and applications. So here is the 4 layers in a TCP IP models. First is the network access, second is the internet, third is the transport and fourth is the application. The following pictures show the comparison between the TCP IP model and OSI model. You can see in the slide we have one side the TCP IP model, one side the OSI model. So in TCP IP model we have the 4 layers: network access, internet, transport, application. And the OSI we already know in the previous slide: physical layer, data link layer, network layer, transport layer, session, presentation and application. So you can see easily here the physical and data link layer relates in TCP IP models with one layer, network access. OSI model network layer relates the internet layer in TCP IP model, transport layer as well as in the TCP IP model transport layer, and the above 3 session, presentation and application layer relates TCP IP model application layer. So as you can see from the picture above, the TCP IP model have fewer layer than the OSI model. The application, presentation and session layer of the OSI model are merged into a single layer in the TCP IP model. Also physical and data link layer are called network access layer in the TCP IP model. Here is a brief discussion of each layer. So link define the protocol and hardware required to deliver data across a physical network. Internet define the protocol for the logical transmission of packet over the network. Transport define the protocol for setting up the level of transmission service for application. This layer is responsible for the reliable transmission of data and the error-free delivery of data packets. Applications defines protocol for node to node application communication and provides service to the application software running on computer. Difference between the OSI and TCP/IP model. Let's see what is the difference between them. There are some other differences between these two models. Beside the obviously difference in the number of layers, that means that OSI have the 7 layers, TCP/IP have the 4 layers. OSI model prescribe the steps needed to transfer data over a network, and it is very specific in it defines which protocol to use at each layer and how. The TCP model is not that specific. It can be said that the OSI model prescribe and TCP/IP model describe. So this is the basic difference of TCP/IP and the OSI model. Next we have local area network, the LAN, you can say. So the term local area network, LAN, is commonly used to describe a network of device in a limited area, a house, office and a building. This type of network is usually capable of achieving high data transfer rate up to 10 Gbps. At low cost, example of this type of network are a small office network inside a single building or your home networks. Or typically SOHO, a small office, home office LAN consists of a PCs, printers, switches, router and cabling that connects all these devices together. The following figures show a typical LAN. So that means the a small office or home office, we have the this limited types of devices like PC, printers and switches. In the picture here we have two computers that are connected to a switch is the connected to a router that provide the LAN with access to the internet. You can see in the picture on the right side, here is the router is directly connected to internet and switch is connected to router, and two computers are connected to switch. So here is the basic example of a network. Some of the most popular LAN technology are Ethernet, Token Ring and FDDI. Most LAN network use TCP/IP to communicate. Twisted pair cabling to usually use in a LAN. So LAN are using the twisted pair cables, and the technology are Ethernet, Token Ring and FDDI also. Ethernet is by far the most popular wired LAN technology. It defines wiring, signaling, connectors, frame, format, protocol rules, etc. Most modern LAN also support the wireless LAN WAN WLAN technology defined by the IEEE 80211 standards. WLAN use radio waves initiated of wires or cables for links between devices. So WLAN is basically the Wi-Fi. We all are using the Wi-Fi. So WLAN denotes the Wi-Fi. So we are also know about this Wi-Fi in our coming next videos. So next we have the wide area network WAN. The term wide area network used to describe a network that spans multiple graphical logical. Consider an example. A company has two offices, one in London and one in Berlin. Both offices have a LAN of the company connects these two LANs together using WAN technology. A WAN is created. So basically WAN is you can say the internet is a very relates to the WAN network, because the internet is a type of network who connects the all types of the other companies and all types of the different networks. The key difference between LAN and WAN is that the company usually doesn't own WAN infrastructure. The basic difference in the LAN and WAN, because the small and a big company is not able to contain a WAN infrastructure because it's very costly. A company usually lease WAN services from a service provider. A company office users are usually taking a service from ISP. A WAN spanning multiple cities would look something like this. You can see here WAN is the internet where the connected the multiple devices, multiple networks with each other with the WAN, which situated in the different graphical area. So you can see in the picture we have some users in Paris, London, New York and India. These all are able to connect with the WAN technology. Frame relay, ATM and X.25 are different type of the WAN technology. These all are the WAN technology. The internet can also be considered a WAN. As I already told you, internet is a big example of WAN. So we have the next Ethernet explained. We are trying to know about the Ethernet. Ethernet is the most used networking technology for LAN today. It defines wiring and signaling for the physical layer of the OSI model. For the data link layer, it defines frame format and protocol. Ethernet is described as the IEEE 802.3 standard. It uses carrier sense multiple access with collision detection, CSMA CD. It uses CSMA-CD access method and support needed up to 100 Gbps. It can use coaxial, twisted pair and fiber optic cables. Ethernet is connected with the coaxial cable, twisted pair cable and the fiber cable also. Ethernet use frames to with source and destination MAC address to deliver data. Basically, Ethernet is connected to the basic computers NIC network interface card, where the NIC have a unique MAC address, and then they easily understand the MAC address of the devices and easily communicate data with the help of Ethernet. The term Ethernet LAN refers to a combination of computer switches and the different kind of cables that use the Ethernet standard to communicate over the networks. It is by far most popular LAN technology today. Next, we have the MAC and IP addresses. First, we have the MAC addresses. MAC address denotes the media access control. Address is a 48-bit, 6 bytes. Address that is used for communication between two hosts in an Ethernet environment. It is a hardware address, which means that it is stored in the firmware of the network card. You can see in the right of your video, here is the example of D8-D3-85-E8-12-E3 is a MAC address that we have the 12 different and or same digits we have. So MAC address has a 48 bits and the 6 byte. Every network card manufacturer gets a universal unique 3 byte called the organizationally unique identifier OUI. Manufacturer agree to give all NIC to MAC address that begins with the assigned OUI. The manufacturer then assigned a unique value for the last 3 bytes, which ensure that every MAC address is globally unique. So you can see here, if the two devices have same MAC address, then what happened? Then simply the devices are not communicating each other, the collision is arrived here. So the OUI defines the all NIC have a unique MAC address. MAC address are usually written in the form of 12 hexadecimal digits. For example, consider the following MAC address. Here the right side you have every hexadecimal characters present 4 bits. That means the every decimal character has the 4 bits. So first 6 hexadecimal characters represent the vendor Hewlett packets in the case. So first 6 we have the represent the vendor denotes, and the last we have the manufacturer denotes. How to find your MAC address? So let's see how can we find our MAC address in the system. So let's very simple with the GUI graphic user interface. You can go in the start and the search for command prompt, and here you type the ipconfig/all. You can get the physical address. So let's see. I am just going to window R. Here type the CMD command prompt, and let's see we have the command prompt. Here let's type ipconfig/all. No, it's not working. So let's config see again ipconfig/all. Here you can see the MAC address. This is the physical, because I have a multiple source of Ethernet in my computer. So you can see here the one by one. We have the one Ethernet adapter, which MAC address is the physical address. This one is the physical address for that Ethernet. I have a also wireless LAN adapter. This MAC address denote the wireless LAN network and wireless LAN Wi-Fi. I have also Wi-Fi. You can see that these and this one is the same because I am currently connected with the Wi-Fi. So this is the physical address, that means the MAC address of a device. So you can easily find it with the help of command and with the help of ipconfig/all. So let's see in the next. IP addresses. An IP address is a 32-bit number that identifies the host on a network. Each device that wants to communicate with other device on the TCP/IP network needs to have an IP address. So basically, the IP address is a address. Suppose if I am sending a letter to my friends, then the basic things I have to know the address of my friends. So if I have the address of my friend's house, then I am easily send any kinds of file, any kinds of courier to my friends. So here is the same as address. So every host have a IP address. So the host is identifiable with the help of IP addresses. An IP address is usually written in the format of 4 decimal numbers separated by periods. The all IP addresses, basically we are talking about here the IPv version 4. So this is the we have the two IPv version, IPv version 4 and IPv version 6. So we are talking about here the IPv version 4. So the first part of the address represent the network the device is on. Example 10.0. We are briefing the IP addresses in our next video. Here is the basic some examples of the IP addresses. This the second part of the address identify the host device. Example 10.0.50.50.1. So here the 10 denotes the network and the 0.50.1 denotes the hosts. In contrast to MAC address, and IP address is a logical address. It can be configured manually or it can be obtained from a DHCP server, dynamic host configuration protocol. We also talk about in our next coming videos. The term IP address is usually used to IP version 4, which is the fourth version of the IP protocol. A newer version exists, IP version 6, and uses 128-bit addressing. IP version 4 uses the 32-bit addressing. Private IP addresses, here you can see there are the three range of the addresses that can be used in a private network. Example in our office, in our home, in our own companies. These addressing are not routable through the internet. That means these all kinds of addresses are not using by any kinds of ISP provider or any kinds of other ISPs. Private address range is the 10 starting from 10 to 10.255.255.255. Second, we have the 172. The first one called the A class private address. The second one called the B class private address, and then third one called the C class private address. We are also briefing these all IPs in our next videos. Here is the short look example of the private IP addresses. So C class we have the 192.168.0.0 to 192.168.255.255. How to find out your IP addresses? Let's see how to find. Same example, if you are want to go in with the GUI, then you have to go in the start, then you have program, accessories, and command prompt for the Windows 7. And the very basic things with the help of your, you can go with the help of command prompt. So let's see. Again, window R, we have the run dialog box open. Here easily type a CMD, and let's see, we have the command prompts, and let's type here ipconfig. Easily hit enter. You can see I have the IP addresses 192.168.40.73. this is the C class private IP addresses. I have the related subnet mask to this address and at the default gateway here. So easily you can find any device IP with the help of ipconfig command. So next we have the unicast, multicast, and broadcast addresses. Let's see, there are three types of Ethernet addresses. First, unicast. Unicast address represent a single LAN interface. A unicast form will be sent to a specific device, not to a group or device on the LAN. That means the unicast send one to one, not one to everyone. Multicast send the one to the in a group. Multicast address represent the group of devices in a LAN. A frame sent on multicast addresses will be forwarded to a group of devices on the LAN. Third, we have the broadcast. Broadcast is also addresses represent all device on the LAN. Frame sent of broadcast address will be delivered to all device on the LAN. If we want to send any file of data to everyone in network, then we can easily go with the broadcast address. If we want to send the multiples users in a network, then we have to go with the multicast. And if we want to send the data with the uniquely one by one, then we have the unicast address. So network devices, let's we have take a look in the at the network devices commonly founded in today's LANs. We have the three network devices which are commonly used in a small office and a big office. In the local area network, first we have the hub. A hub serve as a central point to which all of the hosts in a network connect to. A hub is an OSI layer first devices. That means hub is using in a OSI layer first and has a no concept of Ethernet frame or addressing. It's simply receiving a signal from one ports and send it out to all other ports. Here is an example of 4 ports Ethernet hub source Wikipedia. You can see here the Netgear we have the 4 ports hub. Switches we have second links hub. A switch is used to connect multiple hosts together, but it is many advantages over a hub. Switch is an OSI layer 2 devices. If you have a question which layer using the hub, then you have the answer the layer of OSI layer 1 using hub, and which layer OSI layer using the switch, then you have the answer the layer 2. And the third one we have the routers. A router is a device that routes packets from one network to another. A router is most commonly an OSI layer 3 device. So router is using in OSI layer 3. Routers divide a broadcast domain and have traffic filtering capabilities. The pictures below shown the you have the different netgears, hub, Cisco switches and routers. So friend, this is the things I want to know you. So thank you watching my video, and I would like to request you all, please like and subscribe my video. I am trying to upload my second video as soon as possible, and you all know about the big things about the networks. So thank you so much, take care, good day, bye bye.